Now let's have some fun. Okay, so this was node A, this was node B, this was node C. All right. So we saw so far that because of the 2 kilo ohm and CGS, the rise at this node was very slow. Because this node rose up slowly. And because this node rose up slowly, it took some time, the voltage took some time to get to VT, and because of that, there was a delay at C. All right, so what do we do? Okay, let us try to speed up our inverter and see if we can change the behavior and make it go faster at node B. So what I'm going to do, okay, is try to speed up this little circuit here. Okay, speed up node B in particular. So how might I do that? Okay, how might I go ahead and speed up node B? Well, I have to reduce the time constant, and we can say, hey, let's go change CGS. But CGS is there. I didn't want it to begin with, so I can't change that. Okay, I didn't want it to begin with. Then I have not much control over it, and it's there. So the two resistances I can think about. One is the R on for this MOSFET, and if you recall, the falling time constant was very small. Okay, R on was very small, and so the circuit switched down very quickly, as you saw from the demo. The problem was the rising delay. Okay, the rising was very slow, and the rising was because of the current having to go through a 2 kilo ohm resistor and then charge up the capacitor CGS. So, well, the obvious thing to do is then to try to reduce RL, or the 2 kilo ohm resistor. So why don't I do the following? Okay, in the demo that I've set up for you, here's what I've done. Okay, I've put a very small resistor, in this case 50 ohm resistor, across the 2 kilo ohm in parallel with the 2 kilo ohm resistor, and I have connected a switch like so. Okay, so what I can do is, if I close the switch, okay, if I shut the switch, then the 50 ohm resistor comes in parallel with the 20 kilo ohm resistor, 2 kilo ohm resistor, making the effective parallel resistance more or less 50 ohms, and that should speed up this little node really well. Okay, so if this was time and this was VB, and this is what I have so far, and if I switch to the 50 ohm resistor, what do I expect? I expect something to look like this. Okay, this was 2 kilo ohm, and I expect something to look like this. My 50 ohm to be much faster. Okay, I expect it to shoot up very quickly and get to its 5 volt value. Okay, so let me write down 5 volts here. Okay, so to recap very quickly, this is slow, the circuit is slow, VB is rising slowly, so I say, hey, let's reduce the resistance value through which the capacitor CGS is charging, and that should make it charge up much faster by reducing the time constant. Okay, so I'm going to stick this 50 ohm resistor in parallel with the 2 kilo ohm resistor just for fun here to make my circuit go faster. That's the obvious thing to do. And I'm going to do that for the purpose of the demo, so I can switch it on and off, switch it into the circuit and out of the circuit, so I can show you the demo. I'm going to put a little switch here. Okay, so what I'll do is I'm going to show you another demo, and I'm going to close the switch. Okay, I'm going to close this switch here like so, and I'm going to show you a demo. Okay, with the 50 ohm in parallel. And you will have some fun, a lot of fun. Okay, so let me just write down what I'm going to be doing, and then let's dive into the demo. And I won't tell you what you're going to see, and I will just surprise you. Okay, you will. It's a mind-blowing experience in terms of what you're going to see next. Okay, let's just quickly write this down. Okay, so there you go. I've written that up so you have it in your notes, and let's dive right into the demo and see some really, really fun stuff. Okay, so remember, you expect to see a much faster rising waveform, and you expect your troubles to all go away. Okay, but this is just the beginning of a really interesting problem.